Okay, we are going to continue studying the data center networking. Okay, so let me remind you some historical facts that, for example, we have big organizations, companies like Google, YouTube. So these companies, they need high computing and storage capabilities. Okay, they require, and there is computing and storage requirements, they cannot be fulfilled by a general PC. Okay, so at the start these like big organizations, they were needing to, so they were going to buy, they were buying the mainframe uh, computers. So this was a specialized computer. It has specialized hardware, specialized operating system, and specialized applications they were running. Okay, so that's why their processing power was very high. For example, it is 100 cores, suppose, and there so is, because they are, due to their specialized nature, they were very costly. For example, uh, it cost, suppose, 100 million rupees. So what is the disadvantage? The disadvantage is, one, that it is very expensive, and second, when this hardware is failed, for example, if there is a problem in the hardware, so the whole system is down. Okay, so the first disadvantage was expensive. It was specialized hardware, so it was very expensive. And second is single point failure. Why? Because if there is a problem in a component, so the whole hardware, it is down. It is down. Okay, so for this purpose, there was an alternative approach that connects multiple PCs, and multiple PC, they appear logically as a single computing or storage entity. For example, uh, one PC is 5 cores. So if you want to achieve the processing of 100 cores, so we need 20 PCs, and these 20 PCs, they will have 1 million cost. Okay, so these PCs, they are connected with each other. For example, here they are connected with each other. Okay, and they appear as a single machine, so they have more processing power than this single mainframe, and their combined storage capability is more than this mainframe computer. Okay, and its cost is also less. Okay, and one of the advantage of this is that if this node is failed, then we can also use, then the other nodes will be available. So this is the flexibility, redundancy, or fault tolerance available. Here in the mainframe, if one component is not working, or if this so the whole hardware, it is useless, it will stop working. Okay, but here if this machine is not working, then we can use the rest of the machines. Okay, so that's why this is called, so when these machines, they are connected to each other, so when and they appear as a single machine, as a single storage, or as a single processing capability. So when the task is received, so we have to divide the task among these machines. So there is a different protocol used for communication among these nodes. Okay, so because their requirements is different from the enterprise network, here a single processing task is to be executed on all those nodes. Or for example, a single file is received, it should be splitted and it should be stored on these machines. Some portion of the file should be stored here, some portion should be stored here, some portion should be stored here. Okay, so therefore its requirement is different, so therefore their networking protocol is different. Okay, so this idea evolves to data center networking. And the data center networking, it has special protocols, and it is not only used, but it is also used in the space exploration application and other things. Okay, so the data center networks, it basically from tens to 100,000 of hosts. There are 10 to 100,000 of hosts, and normally these hosts are connected, and normally they reside, or they are placed in single proximity, in the close proximity. Okay, so normally often closely coupled in close proximity. For example, the Amazon, they have a data center for their e-business. Similarly, the content server like YouTube, Akemi, Apple, Microsoft, they have their own data centers for their own processing capability and for their own storage. Similarly, the Google, it has its own data center for search engines and data mining. Okay, so in these data centers, so the data center, so we in this data center networking, we have specialized protocols. And what are the general challenges? So multiple applications, because there are multiple applications running on. Okay, so each serving massive number of clients, the requests are coming from different clients and the different applications are running. So we have to manage it, that which application should be run on which machine and how. Okay, second is the managing, we need load balancing. Okay, or managing the load. Why? Because if the whole load is put on the single machine, then that machine will be overloaded. Okay, so how we can utilize all the machine equally, so therefore we need the load balancing. Okay, so similarly, as I have discussed, that if the protocol, if the machines are high power, okay, but these machines, they are connected through the networking. Okay, so their networking protocol, they should be of high, more efficient, or they should be faster, they should be efficient, they should be correct. Otherwise, if the hardware is more efficient, the application are ever efficient, but the protocol are not efficient, because the protocol are used, the networking protocol are used for the communication among these hosts, among these servers together. Okay, so therefore we need the specialized protocol. Okay, so the data center, this is an example of data center networking. For example, here these are the here we have different hosts, they are attached in the server rack, they are placed in the server rack, and there is a switch on the top of the rack. Okay, here on the each rack we have different servers. Okay, and these servers are connected with each others. Okay, and there is a switch on each top of the rack. Okay, and these, through this switch, these servers in the rack, they are connected with the rest of the racks. Okay, so we can have a architecture like, for example, on the each server rack we have a switch which is called top of the rack switches. These are the top of the rack switches. Then these top of the rack switches, they are connected to another switch. Okay, like for example this one, this one, so this makes another layer. These are the switches that connects top of the rack switches, and these are called tier 2 switches. And these tier 2 switches, they are further connected with another switches, and these switches then are connected to the routers. Okay, so you can see that this data center, it is connected like this way, and this data center is connected to the internet through a border routers. Okay, so for example, if there is a data coming, okay, and that data should be stored, so first the data is forwarded to a load balancer. The load balancer, it will determine that this data should be stored on this rack, on this rack, or on this rack. So this data should be stored, so the data should be stored on these rack, such that there is equal number of load on each rack. Okay, or for example, we received a request for processing a task, and that task is computation extensive. Okay, for example, it needs it will run in 3 days. Okay, so if this task is received, so the load balancer will determine that where should be this task executed, whether on this server or on this rack or on this rack. Okay, because so that so the load balancer working is that these servers, they should be used equally, they should be used efficiently. Okay, so therefore we need a load balancing. So the load balancer application, it is an application layer routing. It receives external client request and direct workload within the data center. So it receives the request, and then it forwards the request to on these servers, so depending upon that which server is free, so that these all services server they are used equally. Okay, and then when this server they for example return the results, then the load balancer combine the results from all these servers, and then that result is sent back to the requesting node, and then return the result to external client. Okay, so basically the load balancer, for example here you can see that it receives the request, that request is distributed. Okay, you can see that we received a request, the load balancing distribute the request among these server racks. Okay, and then when when the requests are processed, then the result is returned back to the client. Okay, so basically as I have told you that the data center, it is also required that how these servers and these switches are interconnected. Okay, so for this purpose we need specialized networking protocol. This is called data center networks. Okay, and their protocol, their working, they are different than enterprise networks. Okay, so we have, and this is an architecture for networking, and in this architecture you can see that the each server rack there is a switch. This is called top of the rack switches, TOR switches, and these top of the rack switches they are connected through tier 1 tier 2 switches, and these tier 2 switches are connected to the top layer switches. Okay, so you can see that if this server rack wants to communicate with this server rack, so it cannot do communication directly, but this server will communicate to this switch, and this switch will communicate to tier 2 switch, and tier 2 switch will communicate to this switch, then this switch will communicate to this switch, and this switch will communicate to the server. Okay, so this is called Valley protocol. Okay, basically, and why it is done, you can see that this switch is connected to this switch and this switch. Okay, the switch is connected to multiple switches, so from one switch to another switch we may have multiple paths. Okay, so if one path is not available, then we can use another path. So there is rich interconnecting among switches, and this is one architecture of for data center networking. And here we have rich interconnection among switches. We have multiple paths between switches, between two switches, so this increase throughput between racks. So there are multiple routing paths. So if we receive a request, for example, if we want to move the data from this server to this server, so we can, when this data will be forwarded to top of the rack switch, the top of rack switch will forward the data to tier 2 switch. This tier 2 switch has 3 paths, so the half traffic will be forwarded to this path, half traffic will be forwarded to this path, and the rest of the traffic will be forwarded to this path. Okay, so it basically increase the reliability and why redundancy. If one path is not available, then we can use another path. If one path is overloaded, then we can use the other path. Okay, so this is the data center networking, and we have so this chapter number 6 is finished. Okay.